Hello everyone, my name is Hussein Al-Hamali and I am a student of Master of Engineering Management program in King Fahd University of Petroleum and Minerals KFUPM. I'll present the article titled Industry 4.0, a survey on technologies, applications and open research issues. This article is from Journal of Industrial Information Integration, published in April 2017, and presented by Yang Lu from University of Kentucky. The article is talk about the fourth industrial revolution has attracted much attention in the recent literatures. It is closely related with Internet of Things (IoT), Cyber Physical System (CPS), Information and Communication Technology (ICT), Enterprise Architecture (EA), and Enterprise Integration (EI). Despite of dynamic nature of research on Industry 4.0, systematic and extensive review of recent research has been unavailable. Accordingly, this paper conducts a comprehensive review on Industry 4.0 and presents an overview of the content, scope, and findings of Industry 4.0 by examining the existing literatures in all databases within the Web of Science. Altogether, 88 papers related to Industry 4.0 are grouped into 5 research categories and reviewed. In my presentation, I'll go through introduction, methodology, Industry 4.0, the state of art, and we will discuss about concept and perspective of Industry 4.0, cyber physical system based Industry 4.0, and interoperability of Industry 4.0. Also, we'll talk about the key technologies of Industry 4.0 and application of Industry 4.0, such as smart factory and smart product and smart city. Modern industrial development has lasted for several hundred years and has now the era of Industry 4.0 come. The concept of Industry 4.0 was initially proposed for developing German economy in 2011. Up to now, there are 4 revolutions of industry as you see in the picture. First industrial revolution began at the end of 18th century and was represented by mechanical production plants based on water and steam power. Second industrial revolution started at the end of 19th century and the beginning of 20th century with a symbol of mass labor production based on electrical energy. Third industrial revolution began between 1969 and 1970 with a characteristic of automatic production based on electronics and internet technology. Right now, the fourth industrial revolution, Industry 4.0, is ongoing with a characteristic of cyber physical system (CPS) based on heterogeneous data and knowledge integration. Industry 4.0 encompasses numerous technologies and associated paradigms, including radio frequency identification (RFID), enterprise resource planning (ERP), Internet of Things (IoT), cloud-based manufacturing, and social product development. The goals of Industry 4.0 are to achieve a higher level of operational efficiency and productivity, as well as a higher level of automations. The 5 major features of Industry 4.0 are: number 1, digitization, optimization, and customization of production. Number 2, automation and adaptation. Number 3, a human-machine interaction, HMI, value-added service and businesses, and the last one, automatic data exchange and communication. This paper conduct a comprehensive review of Industry 4.0 and present an overview of the content, scope, and finding of Industry 4.0 by examining existing literatures in all databases within the Web of Science and Google Scholar. 88 papers related to Industry 4.0 are grouped into 5 research categories and are reviewed. In methodology, we will see the way that the writers choose to identify the 88 papers he chose. This study follows the two-stage approach initiated by Webster and Watson to conduct a literature review. This approach has the capability of locating rigorous and relevant research and then guaranteeing the quality and veracity of the articles finally selected. The process of this approach is shown in the left figure. At the first stage, the word Industry 4.0 was chosen as a keyword to search published papers from 2011 to 2016 collected by Web of Science and Google Scholar. The search returned an 103 results, which indicate that Industry 4.0 is an emerging research topic. Next, citation of these 103 papers were extracted from Google Scholar. At the second stage, the 103 papers were carefully reviewed and unrelated papers were dropped. At the end, 88 papers were left. The chart on the right shows the number of articles and time cited from 2011 to 2016. As you see, the annual average of published paper on Industry 4.0 was 13 and the average annual citation is 157. The annual number of published paper increased from 1 in 2011 to 33 in 2016. A quick increase occurred in 2014 from 1 in 2013 to 11. Annual citation of this paper research reached the peak in 2014 with a number of 461. The change in the number of published paper and citation indicate that Industry 4.0 began to attract attention in literature from 2014. The 88 papers are then grouped into 5 research categories as shown in the below table. The distribution of the categories indicate that more attention has been paid to technologies, tools, and applications regarding Industry 4.0 in recent literature. This indicates that Industry 4.0 is not only an integration of CPS, ICT, enterprise architecture, and IoT, but it is also an interoperability process. In this section, we will summarize the content of selected 88 papers. First point, concept and perspective of Industry 4.0. Scholars have defined Industry 4.0 from diverse perspectives in this research category. For instance, according to consortium, Industry 4.0 is the integration of complex physical machinery and devices with network, sensor, and software used to predict, control, and plan for better business and social outcomes. While Herman defined Industry 4.0 as a collective term of technologies and concepts of value chain organization. They point out that over the IoT, CPS communicate and cooperate with each other and the human in the real time, and that the Internet of Service, both internal and cross-organization services, is offered and utilized by participation of the value chain. So far, there is no unanimously adopted definition of Industry 4.0. There are many goals of Industry 4.0, such as to provide IT-enabled mass customization of manufactured product, also to make automatic and flexible adaptation of the production chain, also to achieve IoT-enabled production optimization in a smart factory, and to provide a new types of services and business models of interaction in the value chain. The principles of Industry 4.0 are interoperability, virtualization, decentralization, real-time capability, service orientation, and modularity. In terms of features, Industry 4.0 can provide more flexibility, reduce the lead time, customize with a small batch size, and reduce the cost. Based on the purpose in this research category, Industry 4.0 can be summarized as an integrated, adapted, optimized, service-oriented, and interoperable manufacturing process which is correlate with algorithms, big data, and high technologies. The second point in this section is CPS. Cyber Physical Systems, CPS, are expected to offer promising solutions to transform the operation and rule of many existing industrial systems. CPS are industrial automation systems that integrate innovative functionalities through networking to enable connection of the operation of the physical reality with computing and communication infrastructures. Shafiq defined CPS as the convergence of the physical and digital world by establishing global networks of business that incorporate their machinery, warehousing system, and production facilities. Monostory, on the other hand, notes that CPS are a system of collaborating computational entities which are in intensive connection with the surrounding physical world and its ongoing process, providing and using at the same time data processing and data accessing services available on the internet. CPS consists of microcontrollers that control the sensor and actuators. CPS are capable of increasing productivity, fostering growth, modifying the workforce performance, producing higher quality goods with lower cost via the collection and analysis of malicious data. Shafiq asserts that a combined structure of virtual engineering objects, virtual engineering process, and virtual engineering factory is a specialized of CPS. Monostory noted that both CPS and the Cyber Physical Production System (CPPS) of Industry 4.0 will be activated and enforced by development of computational entity, data-related procedures, manufacturing automation and technology, and information and communication technology (ICT). They further point out that CPPS will dominate manufacturing system by integrating with CPS as a new generation of industry. CPPS involves humans, machines, and product and combines computation, networking, and physical process together in the production process in order to make the production more cost and time efficient with highly qualified products. The third point in this section is interoperability of the fourth industrial revolution. Industry 4.0 has two key factors, integration and interoperability. According to Chen, interoperability is the ability of two systems to understand each other and to use functionality of one another. It represents the capability of two systems exchange data and sharing information and knowledge. The interoperability of Industry 4.0 will synthesize the software component, application solution, business process, and business context throughout the diversified, heterogeneous, and autonomous procedure. The architecture of interoperability of Industry 4.0 includes four levels: operational, systematical, technical, and semantic. The operational illustrate general structure, concepts, standards, languages, and relationship with the CPS and Industry 4.0. The systematical identifies the guideline and principle of methodologies, standards, domains, and models. The technical one articulate tools and platforms for technical development, IT system, ICT environment, and related software. Semantic ensures information exchange among different group of people, malicious package of application, and various level of institutions. Literature has shown that Industry 4.0 has three frameworks: C4 ISR, IDABC, and Athena. C4 ISR was developed by U.S. Department of Defense in 1996 to integrate the relationship, principles, and guidelines of U.S. militaries. C4 ISR has operational, systematic, and technical level of views. The goal for C4 ISR is to ensure the integration and interoperability among these three levels of view. The second one, IDABC, European Interoperability Framework, EIF version 1.0, provides a reference on interoperability for the IDABC program and delivers pan-European e-government services to citizens and enterprises. The EIF framework implements interoperability through organizational, technical, and semantic dimension. The third one, Athena, it derived from three multidisciplinary approach: enterprise modeling, architectures, and platforms and ontology. Athena offer a holistic approach to deal with interoperability, heterogeneity, and complexity. Athena is able to fulfill user requirement in an entity industry. The next section is the key technologies of Industrial 4.0. Industry 4.0 is marked by highly developed automation and digitization process and by the use of electronics and information technologies (IT) in manufacturing and services. Real-time integration and analyzing massive malicious data will optimize resources in manufacturing process and will achieve better performance. Mobile computing, cloud computing, big data, and the IoT are the key technologies of Industrial 4.0. The development of algorithms for dealing with data will be one of the major challenges in Industry 4.0. In addition, the fifth generation 5G will be acquired in Industry 4.0 to accomplish latent, long, reliable, and secure communication and to meet complex demand of emerging business paradigms. Machine learning algorithm for data mining associated with the cloud services are a direction for future research. The last section is applications of Industry 4.0. The adaptability, the resource efficiency, and the integration of supply and demand process are improved in Industry 4.0. Therefore, factories, production, cities, and potential intelligent equipment and objects become smart. Demonstrating intelligence and knowledge, the term smart is used to refer to application of Industry 4.0 in the literature. According to Stoke and Silger, the main applications of Industry 4.0 are smart factory and manufacturing, smart product, and smart cities. Among the 27 papers in this research category, 13 are about the smart factory and manufacturing, 10 discuss smart production, and the other 4 introduce smart cities. In this part, we will discuss the smart factory and manufacturing. Industry 4.0 make factories more intelligent, flexible, and dynamic by equipping manufacturing with sensors, actors, and autonomous systems. Accordingly, machine and equipment will achieve a high level of self-optimization and automation. In addition, manufacturing process has the capacity of fulfilling more complex and qualified standards and requirements of products as expected. Thus, intelligent factories and smart manufacturing are the major goals of Industry 4.0. Industry 4.0 make value-added integration occur horizontally and vertically in the manufacturing process. Specifically, the horizontal procedure is integrating by value creation modules from the material flow to the logistics of a product's life cycle, whereas the vertical procedures integrates products, equipment, and human needs with different aggregation levels of value creation and manufacturing system. In Industry 4.0, the manufacturing procedure will require more sensor actors, microchips, and autonomous systems due to the quick development of technologies. Advanced methodologies of analytic CPS and energy conversion measures ECM will be implemented in manufacturing as well. The literature shows that smart manufacturing needs the coordination of services and physical flow. The second application is a smart city. Smart city is a city that compromises a sixth factor in its development policy: smart economy, smart mobility, smart environment, smart people, smart living, and smart governance. By combining the internet, telecommunication networks, broadcast networks, a wireless broadband network, and sensor networks, IoT will accelerate the development of a new generation IT and knowledge-based economy. Loom noted that smart city involves technical discipline, economics, humanitarian, and legal aspects. In a smart city, citizens change from user to key stakeholders. High technology becomes the dynamic enabler. Business become partners. Production is based on demand orientation. Products get smart during their life cycle, and transport is a smart service with advanced planning, efficiency, and effectiveness. Smart cities aims to ensure the sustainability of cities, to improve the quality of life and safety of the citizen, and to provide energy efficiency also. However, the transformation from traditional city to a smart city take times. In conclusion, this paper conducts a comprehensive review on Industry 4.0 and presents an overview of the content, scope, and findings of Industry 4.0 by examining existing literature in all databases within Web of Science and Google Scholar. The selected 88 papers are grouped into 5 research categories and reviewed. The development of industry is an integrated process of complexity and agility between a human and machine. Industry 4.0 increases the digitization of manufacturing with CPS, in which connected networks of humans and robots interact and work together with information shared and analyzed, supported by big data and cloud computing along entire industrial value chain. Flexible and efficient production becomes possible in Industry 4.0. Industry 4.0 increases cost and time efficiency and improves products quality associated with enabling technology, methods, and tools. As a result, Industry 4.0 will accelerate industry to achieve an unprecedented level of operational efficiencies and growth and productivity. Inspired by Industry 4.0, China has launched China Manufacturing 2025, which is on the track of Industry 4.0 and moved further. Thank you.